Yes, the subject, zinc. Zinc is probably one of the most touted additives ever in automotive history, and it's won a reputation which it may have deserved 50 years ago, but not anymore. Let me fill you in. First, this product is always referred to as just zinc, or ZDDP. So what exactly is that? What we are really talking about here is a group of compounds which falls into the zinc dialkyl dithiophosphate group. There's actually 3 sorts of this, and they're activated at different temperatures. A good place to find out more about this zinc additive is to go to the Joe Gibbs Oil website. There's a link going across the bottom here, and my friend Lake Speed Jr. gives a pretty good description of what's going on with this chemical. It's quite complicated, but the truth of the matter is it's way out of date. There are better things out there. Let me detail those now. So what might be better than our zinc additive? Oh, let me make a point here. More zinc in the oil does not mean more protection. There comes a time when if you have too much zinc in an oil, it will cause things like the lifters to craze like crazy paving on a pathway. And there's a loss of power and things like this. So zinc, the amount of zinc you put in the oil has to strike a fine balance, and it's different for every oil. There's some oils that are very well blended. You put zinc in, even a small amount, you've now degraded your oil. On the other hand, there's cheap oils which don't have any zinc. You put some zinc into that, and sure enough, they get better. But do you know how much to put in? No. Let's talk about another additive that's replaced or can replace zinc. But I have to make a disclaimer here. Way back, some 25 years ago, I was approached to test an additive called Oil Extreme, and it was a startup company. And of course, it's pretty expensive to hire me for a time to do a test on an oil. It might look like you just throw it in and check it, that worked. No, I had to build an engine especially for the testing, and it had to be a loose engine, i.e. it's one which absolutely would benefit the least from an oil improvement. In other words, it had all the clearances just right for the minimum amount of friction, and at that it made the most power. Basically, it was a 2-barrel circle track engine. It had winning power capability as well. Anyway, we put a 4-barrel carb on it to make testing easier, and I tested the lubricant, right? I did a bunch of tests this way and that, and the oil came out just like the guy who wanted it tested claimed it would. Now here's the interesting thing. You won't believe how many people have come to me, oil salesmen, and said, look, I've got the oil additive, you need to test this, it'll make your career. Right? Why are they coming to me? I've already got a career that's made in journalism, right? I don't need anything. And I said, well, I've got to charge it. No, you don't understand. You need to test this, it'll do wonderful things for your reputation. And I said, I don't need any more reputation, right? If you want this tested, you pay for it. If you're so sure it's going to work, paying for it shouldn't be a problem. Anyway, this guy came into me with Oil Extreme and wanted it tested. And I told him, I said, it's going to cost. And he said, well, okay, how much? And I said, well, I need a deposit of $12,000 and it could be a little bit more after that. Okay, and he got his check out and he wrote me a check for $12,000. Why? Because he knew that if I tested it properly, it was going to work, just like he said. Well, it did. Anyway, the point is this. It was a startup company and funds were tight. That $12,000 he used to pay the deposit was not far off what was in the bank. So I could see that what was going to happen is by the time he'd gone through and tried advertising this and all that and everything else, the company was going to go bankrupt. And you, as a potential end user, would lose a very good oil additive that is at least twice as good as ZDDP. So, I invested in the company. In today's money, it's well over $25,000. Now I have to point out to you that those people, those big automotive celebrity people who advertise additives on TV, we don't have to go into names, you know who they are. They're paid to do that. They don't even test the stuff. Well, probably don't. And if they do, they don't tell you the truth. Now ask yourself this, why would I spend all that money to invest in a product which didn't work just as I'm going to tell you it works? Works damn fine. There we go. That's all you need to know. Now, how do you get this? Just go to the Oil Extreme website and order it, right? It's not cheap, but nothing ever is that's good. Okay, next thing on the agenda, adjusting the lash. Now I say the lash here because it seems like a fairly inconsequential thing, but it can have a great difference. Not quite as much as one hot rod story that I read many years ago that was obviously a paid-for deal. The guy must have been bribed or stupid, one of the two, right? And this was about a dial indicator device for setting the lash on a solid tappet cam. Well, they got on a chassis dyno with a Corvette and adjusted by hand versus adjusted by the lash adjuster, which could adjust the lash to probably better than 1/1000th if you took care of it, was 60 horsepower at the wheels. And I thought, wow, I have got to make one of these for my racing Mini. So I did. Got to the chassis test facility, chassis dyno test facility a few days after I'd made up this device and adjusted my valve train as accurate as I could with feeler gauges. Then dynoed it. Next, adjusted the lash with the lash adjuster to get it just right. I was surprised. I could be up to 2 or 3 thousandths out with the feelers. So it was different, but you know, I've adjusted valves a lot. Now I did this test 50 years ago. Yeah, it's a long time, 50 years ago. Anyway, reran the dyno test and guess what? We couldn't even see a whole horsepower difference. And I came to the conclusion that everything you read in magazines may not be true unless I wrote it. Well, that's not quite accurate. I know that there's some writers out there, and I can name them, who are very trustworthy with their results and they do their testing very thoroughly. But there's also a lot of rip-off artists, and maybe that's a video, a tell-all video in itself, right? These rip-off artists have cost me a great deal of money. If I said $250,000, I would be probably very well on the conservative side. But anyway, valve lash, enough of these stories. Valve lash. Let's first deal with solid lifters, right? There is this tendency amongst many hot rodders, and usually the newer ones, that think that if they adjust the valve lash tighter, then they've got more duration, so it should make more horsepower. Well, the unfortunate thing is that the lift rate is so low on the tappet ramps that it constitutes nothing more than a leak in the system, and usually the power drops. We find that opening the seat valves off their seats fast and closing them fast helps the power output, by virtue of the fact of closing the valves slightly earlier and quicker, usually at the end of the cycle, and this bumps up torque. Now, the best deal is to have the exhaust a little looser than the intake, and that's not because of the expansion. That is because the exhaust is much more influential on the idle quality and the vacuum. May not make much difference on a race motor, but that slight delay between intake and exhaust can make a difference in horsepower. I usually start off with the lash, this is on the dyno, I usually start off with the lash a little on the loose side and then progressively tighten up. First the intake and then the exhaust, and then I go back to the intake. Figure that you're going to probably end up with 2 or 3 thousandths more lash than you anticipated. Now, you can't use too much clearance because it will beat the valve train to death. Also, having that very fast closing on the intake can lead to early valve bounce, and it'll hammer the seats out. So be moderate there. Now let's turn our attention to the hydraulic cams. The standard method here is to adjust the lash down until the push rod just starts to bind up when you try twisting it, and then turn it a quarter turn more. What's the reason for this? Well, if you ask most hot rodders, and for a precise reason, they don't have one. Well, this is what the manufacturers recommend. Well, they do, but not for any performance reasons, other than the fact that a quarter turn into the system will mean that the chances of adjusting the lifters in the next 100,000 miles, assuming the oil's changed, is pretty close to zero. So it's a convenience deal, i.e. you adjust the lifters and you forget them. Now then, are we performance enthusiasts or not? Yes, we are. Why the quarter turn in? Well, like I said, it's just for convenience. If you've got a lifter that is bleeding down, and most of them do, to a certain extent or other, then what happens is the lifter will bleed down, and the chamber in the lifter will have to refill almost in its entirety before the next cycle comes about. So the bleed down causes a reduction in duration, and also it's on the end of the stroke that's most important. That's if we've got headers on, we're going to have that extraction effect. We want that exhaust or intake to be available or give lift at a time when the scavenge cycle wants it. So how can we avoid that? Well, it's quite simple. Instead of adjusting it quarter of a turn down from the top, how about doing it a quarter of a turn up from the bottom? What does this what's the advantage of this? Well, first off, it's very inconvenient adjusting it. You have to empty all the lifters first. Secondly, on the advantage side, we find that the lifter can only bleed down or collapse a short distance before it bottoms out. So that means we have full lift and pretty much most of the duration. The second reason is that it takes very little oil to be pumped into that lifter to fill it up ready for the next cycle. So the propensity for it to misbehave is vastly reduced. When I say vastly, I mean we can go from what will represent 100% problem, right, of collapse. And by adjusting it towards the bottom, we can reduce that 100% problem down to 5%. So it makes a difference. Now, somebody's going to say, what about the pump up? Well, remember, we already went through that. The pump up is due to the spring, not the lifter, right? There is one snag. When you, well, I say one snag, there is a snag you need to take care of. When you adjust the lifters down this far, you must check that the oil comes through the system and comes out of the rockers. Sometimes the lifters don't have the oiling system functional right at the bottom of their travel. Now let's look at the limited travel hydraulic lifters. Essentially, they are lifters which are made so that there's very short amount of travel, and they emulate right out the gate what happens when you adjust a lifter all the way down, right? So that's an area you need to take care of. Now, how much difference can there be in horsepower? Well, that's a good one. Let's take a big block with its need for a high lift in the first place. It's 1.7 rocker trying to give it a high lift in the second place, and a lot of spring on there to keep the valve train under control. We can find that adjusting out the lifter so that it bottoms out rather than a quarter turn in can be as much as 15 to 20 horsepower. So we're not talking about an inconsequential amount. Of course, there's going to be somebody who's got a great set of lifters in there. They dyno it, then they adjust them to the bottom, and it makes almost no difference. Well, the fact of the matter is, you must have tight lifters, and that's good. Last point on this subject. What about those fast bleed down lifters that are supposed to give you more vacuum at idle, and then as the RPM goes up, so they stay pumped up longer and come back up to full duration? Well, the bottom line is they never get fully pumped up again. They never get to the point where they are acting as a true tight hydraulic lifter. They are always bleeding down. Sure, you get more vacuum, but you could have got that by putting in a cam and some stiff hydraulic lifters. The cam would have to be shorter. It would make more torque, it would run quieter, and it'd make more power at the top end, so long as it was chosen correctly. One of the problems with just doing a quick change of lifters to see what power difference can be had from these fast bleed down lifters is that it completely alters the timing of the cam. The bleed down happens on the closing side. So what you effectively do is it advances the timing of the cam all the way forward and cuts the area, right? So when you install that cam and time it, even if the timing figures you were given were correct, the lifters make it incorrect. My advice is think twice before you use fast bleed down lifters. Okay, we've discussed a lot of aspects here, but let's talk about lubrication in terms of how the lifters are oiled. First off, let's deal with the flat tappet stuff because that's the most critical. I think the thing to note there is that Some of the lifters have holes drilled in them, and I've already mentioned that. But one of the ways we need to look at things is in terms of how much oil gets onto the profile of a flat tappet lifter. And there's a way of doing this that is probably better than having a lifter hole, and it works on engines that are particularly susceptible to lifter wear. Big blocks are a prime example. But let's take a look at a simple tool that Comp Cam sells that will lubricate your lifters just right. Here's the device in question. It's a lifter groover. This tool here, this is the diameter of the lifter bore. This tool sticks out slightly. You feed this in from the bottom of the block, like this. Hook this tool in here from the top and pull the lifter up. It grooves it right to the oiling hole that goes from the front to the back of the block. Now that lifter grooving tool that I've just showed you works on solid and hydraulic cams. Especially good for hydraulic cams because it's not practical to put an oil hole in the face of a hydraulic lifter, because then you'll speed up the bleed down rate and the lifter may go into a collapse mode under heavy stresses. Let's now take some roller lifters as an example here. Normally roller lifters are subject to higher loads, but when we get to really extreme loads, the normal roller lifter can suffer from unreliability, and it can actually cause the rollers to break up. Several things you need to consider here. You need to get a roller lifter with as big a roller on it as possible to reduce side loads, and that increases the opening area as well. Not much, but it does. And you need to look into putting as big a lifter diameter as possible so that you can get that bigger roller. Now, let's consider the situation with extreme valve spring loads. And I'm talking 800, 900, even 1,000 pounds over the nose. Maybe more if it's a pro stocker. What you have to do here is you have to get the very best lifters possible. There is a trend to have plain bushings in the roller lifters. Personally, I'm not convinced that they're that much better, if any, than a good roller lifter bearing, right? I've seen both types break under extreme conditions. So just call your cam supplier here and ask them what they think you should use with the profile that you may get, and that should be the best route to follow. Now hopefully I've gone through a lot of stuff here that will help you run your valve train better. Oh, there is one thing I want to mention here. It's a myth that roller lifters can accelerate the valve faster than flat tappet. After all, they look such big square profiles, but if you check out the lift rate, it gets cut down by the fact that that cam that looks so brutishly rectangular is calmed down by the fact that it's running against a roller. Now, if we're talking about going to the limit, a flat tappet cam is capable of accelerating the valve train off the seat faster than a roller. Where it comes to its limitations is in the velocity of the lifter. Once the contact patch has hit the edge of the lifter or close to it, that's it. That's as much velocity as will go into the rest of the valve train. On the other hand, a roller lifter is only limited in the velocity department by how much duration it has. The acceleration of a roller lifter is limited by the side pressure that it experiences, and about 28 degrees is about as much as a typical roller lifter will take. Sure, the pro stocker guys go more than that, but boy, they are running expensive valve trains. You may not want to go there. If you do, then you better do your research really well. Okay, that's it for my lifter session here. Any questions, you put them down at the bottom here, and I'll see if I can get to answer them. As for whatever we're going to talk about now, we'll deal with that in the next video. And so for now, I'm going to say I'll see you next time, and we'll be busy between now and then preparing our next tech video for you. Thank you for watching.